so I think what I'm going to do is go through all of these really with you because there seemed like there was lots of questions about them yesterday. So hopefully that'll get you on more solid ground. And then what we're going to do today is subtracting, which is basically the same. Yeah, so that'll give you a little bit of a chance to practice this stuff, okay? All right, so the very first one, number 11, this one... Going over your assignment from yesterday. What?
Are we going over the whole?
Noelle will tell you. She has it written down. Bailey will tell you. She has it written down. Okay, so for number 11, this should be an easy one to get you started. What do you notice about the two fractions? Yeah, they've got common denominators already. So if I'm going to go 1 over 2x plus 1 over 2x, then I just add the numerators, and that gives me...
1 over x.
Try that again. Try that again. 2 over 2x, okay, because 1 plus 1 is 2 and the 2x's stay the same. And then some of you were sprinting to the finish line there. Then, since I have 2 over 2 and it's all multiplication, there's no addition or subtraction, so canceling is legal in this case. I can cancel this 2 with that 2, and that leaves me with 1 over x. All right? Okay, so that's pretty simple. Number 12 should be simple in the same way because I already have a common denominator. So all I need to do is combine like terms on top. So d plus d is 2d, not d squared. You're adding them, so it's just 2d's. Negative 3 plus negative 1 is negative 4. And then that's over the denominator that we already had, which is 2d plus 1. Okay? Now, your impulse there might be to cancel the 2d's, but you cannot because this is a subtraction and this is an addition, and you can only cancel when everything's multiplication, okay? That's why we factor first and then cancel, because when you factor, you're changing it into a multiplication problem. Now, you might try and factor this because you would notice what factors out of 2d minus 4? A 2, so I can factor 2 out of there and change it into a multiplication problem like that. But then this d minus 2 and that 2d plus 1 are not the same. And so really this is your final answer right there. Okay? All right, so those are just some easy little warm-up ones where you already had a common denominator. Let's take a look at number 15, shall we? Because here's where things start to get a little bit tricky. So for number 15, I have an xy squared on the bottom of this fraction, and I have a 4xy on the bottom of this fraction. What's my common denominator going to be? I need to have everything that was there in both denominators. So since this one has a 4, this one needs a 4 also. Yeah, now you got it. And since this one has a y squared, this one needs a y squared also. So my common denominator there is actually going to be 4xy squared. So you're not doing that thing where you take, what's that, where you're figuring out like the least common multiple or greatest common factor or whatever, where you like take the minimum of the factors. You have to take all of the factors and put them in there. So this is now 4xy squared. It was just plain old xy squared. What did I multiply this by to get this? 4. So I have to multiply the top by 4 also. Okay? So 4 times 5y plus 2 is 20y plus 8. This was 4xy. Now it's 4xy squared. What did I multiply 4xy by to get 4xy squared? It already had an x and a y, so all I multiplied it by was y. Because 4xy times y gives me 4xy squared. Yeah, hold on just a second. So I need to multiply all of this by y. So what's 2x times y? 2xy. And what is negative 4 times y? Negative 4y. Okay, and then this made many of you yesterday unhappy because the 4xy squared on the bottom we feel good about. But on the top, what are the only like terms that we have? The y's. So 20y's take away 4y's is 16y's. But yeah, how come? Plus 2xy plus 8. Which isn't very pretty. hi, Casey. That's okay, thanks. Okay, I'm on Alicia. I don't know if I can make it all the way there. Okay, but there is one tiny little thing that we can do. What can I factor out of all of this? A 2. So I can factor 2 out of there. 16y divided by 2 is 8y. 2xy divided by 2 is just xy. And 8 divided by 2 is 4. And that's still over 4xy squared. So now that I've factored this 2 out of there, what can I do with the 2 and the 4? Hang on just a sec. Reduce them, yep. So 2 goes into there twice. So that gives me a final, very not attractive answer of 8y plus xy plus 4 over 2xy squared. Okay, hold on just a sec. We had a couple questions on our way there. Maddie, what was your question first? How I came up with this? Okay, I had xy squared right here, right?
Yeah.
And I changed it to 4xy squared by multiplying by 4.
Yeah.
So if I multiply the bottom by 4, then I have to multiply the top by 4 also. So I just took the 5y and the 2 and multiplied them both by 4, and that's what I got. Okay, Colin?
How did you get the 16y plus 2x?
How did I get that?
Yeah.
Okay, I had 20y right here, minus 4y's right there. So 20y's take away 4y's is 16y's. And then the 2xy stayed the same and the 8 stayed the same. So those are just there. Okay, Jordan, did you have a question also?
I wrote the answer as xy plus 8y plus 4.
Oh, okay. Yeah, the order doesn't matter when you're doing addition. So you could have those in a different order, okay? All right, all very awesome questions. Any more of them? Okay. All right, so what was the next one? 16? All right, so let's jump to a new page for that. So number 16 is 5x over x squared minus 9 plus 2 over x plus 4. No?
I thought it was 2 minus 3.
No? No? What do I do first? I need a common denominator. Excellent, Maddie. How do I figure out what that common denominator is going to be? I factor whatever I can. How does x squared minus 9 factor?
3 and -3.
Good. X minus 3 and x plus 3. So this is kind of an ugly one because they don't share any common factors. So my common denominator is going to be all of this stuff and this one also. In other words, it's going to be x minus 3 times x plus 3 times x plus 4. All of those have to be in there. Okay? So, what did I multiply x minus 3 times x plus 3 by in order to get this? X plus 4. So what do I have to multiply this by? X plus 4. So that's going to be 5x times x plus 4. We'll do that in a second. What did I multiply this x plus 4 by to get all of this garbage here? Right, x squared minus 9. Yeah, this thing right here. Okay, so you're going to save us a little time and go 2 times x squared minus 9. Okay, so I got the common denominator. Use the common denominator to figure out what my new numerator should be. What do I do now? Distribute. Okay, so 5x times x plus 4 is? 5x squared plus 20x. Awesome. Josie Talley, smartest student in my 4th period class. What do I do here? Joseph Johnson, please. I'm so tired of you not paying attention and not understanding what we're doing. You could possibly be the worst student in my 4th period advanced algebra class. Joseph, please put the knife. Joseph, calm. Okay, what do I do with this? Distribute. So that's going to be 2x squared minus 18. Okay, so now I can combine like terms. So 5x squareds plus 2 more x squareds is how many x squareds altogether? 7x squareds. And then these are the only x's I have, so I'm going to stay as 20x. And then I have to subtract 18. And okay, 2 times 9 is 18. And then that's still over x minus 3 times x plus 3 times x plus 4. Yes, it is. Okay, can I get a little help from McClemkin? Did this factor? No? Okay, so we're done. Do you agree, Hannah? Did you try and factor this? 7x? No. Okay. So should we trust? Should we trust your cousin there? Okay. Samantha, did you try and factor it also? No, but you just don't think it's going to work? Okay.
Well, on the bottom, I have x squared minus 9 and then x plus 3.
Okay, yeah, that's fine. You can write the x minus 3 times x plus 3 as x squared minus 9 if you want. Yep. Okay, and then we just decided that this isn't going to factor 3 and 6, 7, 21. So we're just going to leave it like that. Okay? Okay, what was the next one? 19. Can you read that problem to me?
I don't have it. 3x over x squared minus 9. Oh, wait. Yeah, okay. Plus 4.
Wait. Negative 3x over what?
Minus 9.
Okay.
And then plus 4 over 2x minus 3.
Okay, thank you. All right, so we got some factoring to do here again. X squared minus 9 we should be getting pretty good at. I feel like we're seeing that a lot in this chapter. X squared minus 9 factors into what?
X plus 3 and x plus 3.
Good, x plus 3 and x minus 3. And then 2x minus 6 factors into? 2. Yep, you can factor 2 out because both of good. 2 times x minus 3. Okay, so what's my common denominator going to be?
Ooh, x plus 3, x minus 3 squared?
Nope. 2, because this has a 2, so this one needs a 2 also. And then x plus 3, because this one has an x plus 3, so this one needs an x plus 3 also. And then x minus 3, but they both already had one of those, so I don't need to change it, right? So everything's got to be in there for the denominators of both. Okay, so this guy right here I took and multiplied by 2. So I have to multiply this by 2, so that gives me negative 6x. This guy right here was originally 2 times x minus 3, and then I multiplied that by x plus 3, so I have to multiply this by x plus 3. I'd kind of like to do this in one step because there's so many of them. It'd be nice to compress it a little bit. What's x plus 3 times 4? 4x plus 12. Okay, good. So, got a common denominator. Got my numerators all figured out. What do I do now? Add the x's. So how many x's? Okay, it's going to be negative 2x. Yep. How many plain old numbers do I have? Plus 12. And that is over 2 times x plus 3 times x minus 3. Okay, what can I factor out of the top? Negative 2. And that will leave me x minus 6. Good. Over 2 times x plus 3 times x minus 3. So I have just some little baby canceling that I can do. What can I cancel? The 2's. Okay, so I'm going to just leave it like negative parentheses like that. You could distribute that negative on top if you want and have it be negative x plus 6. You could FOIL this stuff on the bottom if you want and have it x squared minus 9. It all works out to be the same. Okay? Are we getting there? Kind of. Okay, Piper's never going to give me this, but I look this closer. All right, what's the next one? 20. Can you read that one for me, Maddie? No. Okay. Morgan, you want to go again?
5x over x squared minus x
Plus 4? Okay. Okay, so here we go again. What do we do first? Get the common denominator by factoring. So this factors into, what is it? 6 and 1 make 6 when you multiply them, but they don't make -1 when I add them. I need a -1 in the middle. What? -3 and +2. Awesome. Okay, how about this guy over here? 2 and 2. Okay, so this denominator only has one x plus 2. This one has 2 of them. So I'm going to have to put on an additional x plus 2 over here. Right, this one has 2x plus 2's but no x minus 3, so I'm going to have to put on an x minus 3 over there. Okay?
And then you multiply whatever you added.
Yep, you multiply whatever you added onto the bottom. So since on the bottom here I added an x plus 2, I'm going to take the, right, but since this one, it's a great point. This one already did have an x plus 2, but since this one had 2 of them, this one needs 2 of them also. What did you come up with there? 5x squared plus 10x, good. Okay, and then how about for this one over here? 4 times x minus 12. Okay, and once again, for those of you watching at home, that is Josie Talley coming up with answers left and right. And Maddie Jensen with the assist, okay? All right, so now if I combine like terms on top, what do I get?
9x.
No, because this one isn't squared, so you can't combine it.
Oh, 10x plus 5x squared.
So 5x squared plus 14x minus 12 over x plus 2, x minus 3, and another x plus 2. Yeah.
You know those pens yesterday that we were talking about?
Those pens yesterday that we were talking about. Okay, can the top of this factor at all?
Yeah.
You think so?
Yeah.
Let's try a little guess and check. I don't know if this is going to work or not, but if it was to factor, what would have to be in the front here?
X squared.
It'd have to be a 5x and an x to multiply together to give me x squared, okay? And then this 5 changes everything, that's why it's tricky. You don't have to write this down because I don't know if this is going to work. -12 I know is either a 1 and a 12, a 2 and a 6, or a 3 and a 4. So that would give me 15 minus 4, nope, 30 minus 2, nope, and nope, so that's not going to factor. All right, so we're done there, okay? What's next? Huh? Oh, you know what the restrictions are, right? Can't be -2, can't be 3. Okay, which one's next? 32, so we only have 2 left?
Yeah, 3 left.
3 left? Okay. Okay, 32. Okay, what is the common denominator?
It would be x plus and minus 1.
Okay, x plus 1 and x minus 1. Okay, so on the left, originally we just had an x plus 1, and then we changed that into an x plus 1 times x minus 1. So what do I have to do to the top?
3x minus 3.
Good, I have to multiply this by x minus 1, and that will give me 3x minus 3. What did I multiply this by?
2x minus 1.
Slow down there, slugger. What did I multiply this by?
X. Oh, shoot. X
What?
plus 1.
I multiplied this one by x plus 1, okay? So that means I have to multiply the top by x plus 1 also. That's a little trickier. What is x times x plus 1?
2x.
X squared plus x. Good, thank you, Joseph. Appreciate that about you. Okay, so then I have to again combine my like terms. So what do I get on top when I combine all the like terms? No, you Good.
Plus 4x minus 3.
X squared plus 4x minus 3 over x plus 1 times x minus 1. Now this time, the top, nope, still doesn't factor, does it? Two numbers that multiply to be negative 3 and add to be 4, not going to work. Okay, so we're done again there. Any questions about that? I'm waiting. Just change the color of the pen. No big deal. Everything's fine. Okay, 33. What does the denominator on the left factor into? Good. X plus 3, x minus 3. Good. And then on the right, I just have an x plus 3. So what do I need to multiply on the right by? Yep, I need to include an x minus 3 there. On the left, I didn't change it at all, so the 4 is just going to stay as a 4. And on the right, I multiplied by... Right, I multiplied by x minus 3, so if I distribute that 7, it's going to give me 7x minus 21. Okay. And then now all I am left to do is combine the like terms. So 4 take away 21 is negative 17. So 7x minus 17 over x plus 3 times x minus 3. Can't factor the top, so that is our final answer. Okay, and then 35 is kind of a tricky one, but it's worth looking at. 34 was a subtraction one, so I didn't assign it. When you look at just this plain old 3x right here, yeah, that's going to be over 1. So it doesn't look like a fraction, but there's a hidden 1 in there. So I'm going to just write that as over 1. And then the x squared minus 2, since 2 is not a perfect square, will not factor. So I'm just going to leave that as x squared minus 2. So what do I have to multiply the denominator on the left by in order to get a common denominator? X squared minus 2. So what do I have to multiply the numerator on the left by? X squared minus 2. Okay, so that's kind of a weird one because the one on the left wasn't really a fraction, but you can always make it into a fraction by just putting it over 1. So now if I distribute the 3x, what is 3x times x squared?
X cubed.
3x cubed. And what's 3x times minus 2?
6x.
Minus 6x. And then I have still, from this other one, an x squared and a 5x. And that's all over x squared minus 2. What are the only like terms for me to combine on top?
X's.
The x's. So that would give me a 3x cubed, an x squared. Those stay the same. But then negative 6x plus 5x is
X.
negative x. And that is over x squared minus 2. Okay? Yep, that's the answer. And that is your entire homework assignment done for you. I could factor out an x. Yeah, you're right. But since I can't factor one out of here on the bottom, there's no canceling for me to do. Okay? All right, will you pass those forward, please? Okay, so today we are going to wrap up this section. The first thing we have to do is fairly simple. There's just one tiny little trick in here when you're subtracting rational expressions that trips up a surprising number of students. Okay, I'm just going to do one quick example and hopefully that'll get that going for you. So to start with, the process is the same. I need to get a common denominator. And in order to know what my common denominator is going to be, what do I have to do? Factor. So, Austin, what does x squared minus 2x factor into? How can I factor that? Austin. Yeah, I can take out an x. And if I take out an x from x squared, Austin, what am I left with? X. And if I take an x out of negative 2x, what am I left with? Negative. If I take an x out of this, what am I left with? Negative 2. Okay? Okay, Jasmine, what can I factor out of 2x minus 4? Good. And when I do that, what am I left with? X minus 2. Good. Okay, so now that we have that factored, what do I need over here that I have over here? The 2. So I'm going to need a 2 right here, which means I'm going to need a 2 on the top. What do I need over here? From over here. Good. I need to have an x, so that means I am going to have an x on the top. Okay? All right, so then that means I have x plus 2 here and x plus 2 there. From the original problem. Why is there what? Right here? Because this one had a 2 and this one didn't, so I had to put a 2 into there. And if I put a 2 into here, I have to put a 2 on the top also. Okay? Okay, then I need to distribute this 2, so that gives me 2x plus 4. And then on this one, I have to distribute this x, which gives me, okay,
X squared plus 2x.
X squared plus 2x. All right, so far, nothing that I have done is different from what we did yesterday. Here is where the fun begins. Yeah, here's the catch. Okay, so my common denominator was 2x times x minus 2. So now I'm going to go through like I have been doing and combine my like terms. Piper, if I can get you up here for a sec, this is the important part. This is minus x squared plus 2x, okay? Colin? The negative distributes to both of these terms. And that's the mistake that so many students make, is that you have a tendency to subtract the x squared, but then to add the 2x, okay? But you have to subtract both of these terms here, okay? So this x squared becomes a minus x squared because of that negative. And then what happens to this 2x and this 2x right here? They cancel. Good, because this isn't 2x plus 2x, it's 2x minus a positive 2x. So the 2x's cancel, and I'm just left with negative x squared plus 4. Okay? So remember, when you're subtracting fractions, that negative sign goes through all of the terms in the numerator. Okay? All right, now we do have a little bit of fun to do. I am going to take negative x squared plus 4 and rewrite it as 4 minus x squared. And that hopefully allows you to recognize that this is a special factor pattern. Difference of two squares. So 4 minus x squared factors into, but the x is at the end this time. It's the end is, so what? 2 minus x times 2 plus x, okay? And that's still over 2x times x minus 2. So what do you notice about 2 minus x and x minus 2? They cancel out, but they're not the same. They are opposite of each other. So when they cancel out, they don't cancel and make 1. They make negative 1. So when I cancel opposites, I need to throw a negative in there. So my final answer is going to be negative 2 plus x over 2x. Okay? So you can cancel an x minus 2 and a 2 minus x, but you have to throw a negative in there because they are opposites. All right? Okay, so hopefully that's not too bad, right? Because all we did was subtracted instead of added. So you good with that? Okay, the really exciting part of this is when we are doing what's called complex fractions, which is when I have fractions inside of fractions, fractions over fractions, fractions being added to fractions, divided by fractions, being subtracted by fractions. So it's like a big old fraction party, okay? So let's try one of those. When you have a problem that looks like this, it's basically a 2-for-1 deal for you, okay? So I'm going to look at these as two separate problems. The first problem that I have to solve is 1 over x plus, really? My phone is ringing? I had no idea, Josie. Thank you for pointing that out. Okay, so if I have 1 over x plus x over y, what is my common denominator going to be? 1 over x plus x over y. What's the common denominator going to be? What does this have right here? Right, I need an x and I need a y. This has an x and this has a y. So to make a match, I need an x and a y in both of them, okay? What did I multiply this x by? So what do I have to multiply the 1 by? All right? What did I multiply this y by? X. So what do I have to multiply this x by? X. And the x times x is going to give me x squared, okay? All right, then on the bottom, what is my common denominator going to be for these two things? Y. Good. So this one doesn't change because it was a y before. It's going to stay a y now. What do I have to write on top to make this work? Yeah, a y, because I multiplied that by y. And that should kind of make sense because y over y would cancel and give you 1. All right? So now that I have common denominator on top, I can write this as just one fraction, which would be x squared plus y over xy. I also have a common denominator on the bottom, so I can write this as one fraction, which would be, anyone? Bueller? What? What do I have on top? Hannah, don't do that right now. Yeah, I did. Bueller? Bueller? Yeah. Anyone? No? 1 plus y. And that's over y, okay? So hey, girls, two separate problems that you have to do just like the ones that we were doing before. Get a common denominator and then combine the like terms, okay? That gives me this fraction on top and then this fraction on the bottom. What do you do when you have two fractions that you're dividing? Right, you multiply by the reciprocal. So now I'm going to take this and I'm going to rewrite it as x squared plus y over xy times, I'm going to take this one and flip it over. So I'm going to go times y over 1 plus y. Okay? And then now we can do any canceling again. So what cancels on the top and the bottom of this? The y. And so my final answer is x squared plus y over x times 1 plus y. Okay, so those are challenging problems. That's why they're called complex fractions. There's a lot going on there. You have to get a common denominator on the top and then combine those, common denominator on the bottom, and then combine those, multiply by the reciprocal, and then cancel what you can. Okay? Tons of those, Hannah.